Hello, everyone, and welcome to How to Build an OpenAI LLM on a Private Network with AWS. My name is Matt Brown, and I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you're currently in a listen-only mode. You may submit questions throughout the session using the Q&A functionality in the lower section of your Zoom console. If this is your first time joining a SingleStore webinar, heads up that we present weekly technical workshops demoing data and AI use cases and new technologies. In fact, next week, we will be presenting how to build an OpenAI basketball referee system with computer vision. If that topic sounds fun to you, you can feel free to register right now at bit.ly/OpenAI basketball referee. Wes, would you mind clicking to the next slide? There we go. I will put this link in the chat as well. All right, back to today's topic. FYI, we have fantastic technical experts joining our Zoom Q&A. They have a great grasp of AI technologies, and they are ready to answer your questions interactively. Welcome Eric Hansen and Akmal Chowdhury. We'll try to get to as many of your questions as they come in, so feel free to submit throughout Wes's presentation, and I will also flag some for our live Q&A at the end of the session. Also, after today's webinar, everyone will receive an email with the recording. All right, so let me quickly introduce our speaker for today. Wes Kennedy is a senior technical evangelist at SingleStore. He has strong expertise in big data, machine learning, and AI. He's a prolific author. He's a regular speaker at our weekly webinars. Welcome, Wes. You now have the floor.
Yeah, thanks for having me. Yeah, so today we are going to focus on how can we build our own private LLM. So I can imagine a large amount of you are here because of the privacy aspect of the LLM world and wanting to learn how we can implement that inside of our own data center, whether that be inside of AWS, inside your VPC, or linking into applications that are running inside your data center. We'll cover all that today. A little bit of background on why and where, why are we focusing on this? Where do we see the world heading? Basically, we see that we're going to have apps that are both going to be data aware, which is basically just they're going to have just general intelligence, but they're going to have memory associated with them. So the idea being, I have an application, I'm interacting with it back and forth. It's generating AI responses, and it's going to remember those in that conversation flow. If you've used ChatGPT inside of a conversation flow, you've definitely seen situations where you feel like it got hit in the back of the head and it lost the context that you had before. That's where memory really comes into play. We're definitely going to see more and more applications where it needs to have that memory. On top of that, we're going to have more agentic applications, which means that AI apps are actually going to be able to make action upon what you're asking them to do. So I'm sure some of you have interacted with, say, maybe an airline chatbot or something like that, where you just need to change your flight, and it can actually do some of that stuff on the background for you. And that's basically what an agentic app is. Just think of it as anything that would have a call center agent on the other side. It's the same thing, but we're going to do it with AI. Now, being a data-aware application, it doesn't just work out of the box. Just like you can't give ChatGPT all your custom data, and you can only give it so much information as context. So the idea that you can only give 40 pages of context is kind of limiting when you're building something and interacting with ChatGPT, which I think is a really powerful feature of being able to bring that stuff inside your data center and either train your own models or expand the context that you can feed into that model with its responses. And being data aware means that you actually need to have that custom data in there. And that custom data needs to be live, it needs to be real time, and we need to be able to remember what the conversations are and what that feedback is. So, the other day I was using ChatGPT to develop a Python application, and I kept having to remind it that I needed all the inputs to be dynamic no matter what. And some of its outputs always wanted to create an array of possible responses and then choose from those. And I kept saying, no, I need you to look up and find the best of X and use that to then look up the next piece of the puzzle. So the long-term memory really becomes important, and it also becomes something that we can use to help improve our models as we go. And then the short-term memory, I guess, is more what I was discussing before, where it keeps the context of the conversation, whereas the longer term is the actual conversation flow that we can then review down the road. So why should you build a private LLM? Aside from just providing privacy for your company and your customers and the users of your application, you want to protect that data that you already own. It also gives you many other features, such as it being much faster. A lot of times I've seen some responses that tend to be quite slow, in my opinion. Sometimes it's probably because it's calculating on the back end its response, but the other times I believe it's just overload of a system. When you own that system and you can scale it out as you need, that's when you can help provide more reliable performance for your applications. You can train custom models on your company data to ensure that the model itself has more context and it's more accurate. And then as your data continues to expand, rather than continuously retraining that model, you can then feed in the additional context from that data as it expands. One of the things you'll see is the more and more you use something like ChatGPT, you'll start chewing up tokens. And your tokens are spent in kind of an opaque way. You don't, I mean, it's not very obvious to me as I'm doing it. You can get information back from the AI API about what each request is going to cost to make a determination if you want to send it or not. But being able to run your own LLM inside your data center means that you're not reaching out to all these other these APIs that then you have to control the costs on. And then by building an API to front your private LLM, you make it available to all the other applications inside your data center. So, you may have only one app or a chatbot or something like that that you want to connect it to today. But in the future, more and more apps are going to become tied into AI, and they're going to want access into more of your company data. So building an API to even just create embeddings alone will help make you more efficient. And will it be difficult to build? I mean, as everything in IT, the answer is it depends, but really it's not all that difficult. It will take some time and some work, but the information's out there. There's a lot of great tooling. We're going to walk through a lot of the high-level decision-making that you have to go through today. We'll look at some pseudocode along the way. And then also I will demo our chatbot Squirrel and how we can use that inside of our notebooks feature to help develop code and things like that. But Squirrel was trained on our company data, has access to all our documentation, SQL documentation and best practices, your databases, and really helps you make the best decisions and helps you write the code that you need. So I've broken it down into three main pieces today. So it's basically, how do I make decisions about the software, the infrastructure, and then the model itself? And we'll dive into those one at a time. So the software needs to be easy to integrate. I would say in it being easy to integrate, that means it needs to be in a language that your team is used to using. So that doesn't mean, oh, today I'm going to go learn Rust because that's what it was written, what this program is written at. The good news is a large majority of the software frameworks out there for AI are either built on top of Node or on top of Python, which are both very easy to jump on top of, but they're also something that a lot of developers out there are comfortable with. It does need to present a simple API for your app developers. So that comes back to like, how are the SDKs built? Are they easy to consume and understand? And then are they well documented? So there are a number of different software platforms we're going to talk about today. I try to kind of mention alternatives down at the bottom as we go. Hugging Face is really interesting because they are an open place where you can share models, data sets, and so much more. What's really cool about this, it's not only is it just like a community of sharing, but they also have ways that you can query some of those models directly from the website. But more than that, they also have Python modules that you can use, and I think a few other types of modules that you can use to directly query the data sets and models that exist there. Beyond that, you can use Hugging Face to take a model that you have and use it to, say, split the data into 80% production data, 10% testing data, and 10% QA, or whatever that is. And you can use that to ensure that the model that you're building is actually working very well. So there's a lot of tooling that they offer there. There are a lot of alternatives to each and every piece of what Hugging Face does. There's not a lot of places that offer kind of the whole ecosystem. So really at the end of the day, you're going to end up doing a lot of manual working with the data sets, parsing them, splitting them, and then moving on to figure out how to do your training and testing. So Hugging Face really just kind of makes that a simple process. Everybody's familiar with OpenAI. Obviously, they're the ones that released ChatGPT. The GPT 3.5 and 4 models are obviously out and available for use. They are very powerful. There are several models. We'll talk about them here in a minute. But the idea here is they're only really good at either generating that text or that audio in that next word. Where it gets really good is when you start feeding it additional context from your own data. And if your own data has then been reordered in a way that makes the most sense, and you selected the top 5 responses, and you can feed those in as well, it really helps ensure that you're getting powerful and useful results. Beyond that, they have a lot of APIs that you can use. You can query OpenAI just like you would a chatbot, but you can also use them to create your own embeddings. You do pick the model and things as you do that. For today, I've actually gone down the path of showing how to kind of stand up your own embedding or your own way of creating embeddings, which we'll talk about in the next section. There are many alternatives to OpenAI, Google Bard being one of them. There are a number of others. AWS has something coming out soon, but I think at the end of the day, most of them use the same underlying GPT data set. And it's a matter of how the intelligence that sits on top of that works is a little bit different. But there are others out there. And if you go onto Hugging Face, you can click on models and you can see all sorts of models that are based on many different things. So using Hugging Face, we'll do a little pseudocode here. We're going to use their transformer modules, import a few pieces here, the tokenizer, and then we're going to select the OpenAI-GPT model. And as we worked through the code and things like that, you can refer to this model as model dots and then run the commands that you need to use against that model. So pretty simple to use something like this. I ran it locally on my laptop just a few minutes before the webinar here and pulled down the model, and it kind of does all that for you and takes care of it. Obviously, if you're wanting to store this in your data center, then I would want to take that model, store it locally, and then the actual transformers module has options to then access it locally instead of continuously pulling from OpenAI. So talking about vector embeddings, using something like Espert's sentence transformers, we can create our own embeddings locally. We can use that with an internal AI, such as something like Fast API, to ensure that you have no variation in the method in which your embeddings inside your company are created. This is an important thing to note. One, it enables data portability inside your company, because if somebody goes and chooses a different model, then the way in which those embeddings are created aren't necessarily compatible, because the model that is used to create those embeddings is different. It performs different. The neural network inside is created differently. So this is why I'm a big proponent of creating those embeddings internally inside your data center. Then, of course, storing them, and we'll talk about that in a little bit. There are a number of alternatives. Face, Annoy, HNSW, Face being from Facebook. Can't remember the other two. But there are definitely other options out there besides the OpenAI embeddings module, besides the sentence transformers here. So just dumped a bunch of code on your screens here, but basically what you're seeing on the left is using Fast API and the sentence transformers module. First up, we set up the model, the sentence transformer, all-mini LM. We create our Fast API as app. We create a class, which is basically how Fast API parses the JSON input that it's expecting. And for now, I just left it open as a string. I would recommend using something like image, text, JSON, etc. Excuse me. And then we create a route down below, this route being a post. So you would either curl or use the request module or something like that to create a request out to create underscore embedding. In there, it would expect a payload. That payload I've got in the top right-hand corner of your screen. All it is just a type of text. Hey, this is a text based embedding I need to create. The reason why I'm including that is you may want to choose different models if it's text versus images versus JSON or whatever.
Hey, Wes, quick point. I noticed your audio just changed, and a couple folks have mentioned that in the Q&A. Did your microphone maybe unplug from your headphones?
Is that better?
Perfect. There. Thank you.
Okay.
And thank you
yeah,
for the
it decided to
audience
use my iPhone for some reason. That was weird.
All right. Thanks.
So we create the route for the post, and when a post comes in containing that payload, it's going to do a very simple strip of the request.content, send it into our model, which is that sentence transformer, and it's going to create the encoding. Let's see where I've got. And after it's done, it adds it to the variable embedding, and then it returns it back to your client. Obviously, this is a very simplistic example. You would definitely want to expand it a little bit more, add some additional logic for the type handling, things like that. But it works for us today. We're actually going to expand it a little bit more here in a moment. Now, we're creating all these embeddings for all our data. We don't want to create them every time we want to interact with the data. It's not very efficient. So batching that process makes a lot of sense, especially if the data remains fairly static, because you only need to update the embeddings on a trigger of that data being updated, right? So if you write to a row in a database, you don't need to go back and update that embedding every time you use it. You only have to update the embedding when something changes for that data. So in our case, there are a lot of vector databases out there, which we'll talk about a few here soon. We offer native support for more than just vectors. And that's very important because, as we've talked about, context is king here. So being able to put in your relational, your NoSQL vector data, JSON, geospatial, all sorts of other data types that we support, and have them all in a multi-model database is really powerful. On top of that, us being a real-time database, meaning that you can get your queries in milliseconds and be up to date and always acting on live data is extremely important. SingleStore can be hosted either in AWS through AWS Cloud as a service, and we'll talk about how we can link into that using AWS Private Link in a moment, or we can run on-prem as well. So you can either run that inside of an EKS cluster on AWS, or you can run it in an old school data center that you're still running. It's up to you. We're flexible, we're powerful, we scale up, and we're highly performant. So going back to our example here where we had just those few supplied keys, and if I wanted to just create a table that stored all of my embeddings, then here's the rough SQL I would use to do that. So create an ID that auto increments. Here's the supplied ID. So basically like an internally referenceable ID. A lot of times that would be referencing maybe another column somewhere else in a different database or a different table. And then the type is this text, image, whatever, and then the embedding itself. And the embedding would be stored as a blob. Now, in the SQL or in the Python side of the house, in building out our actual API here, we're going to just create that engine connection out to our database. And then we're going to need a function that will basically take all of that and store that data inside the database itself. So the SQL query here we're defining is insert the data into my table into these three columns, the values of brackets, brackets, brackets. And then we're going to insert using the .format method, the embedding ID, the type, and the embedding. And the idea here is I want to be able to store in what is that externally referenceable ID that we were passing in, the type, and then the embedding itself. And then we're going to do a super simple db.execute with this new query, and we're off to the races. Now, if we go back down below, it's the same request or the same route for that create underscore embedding. I just added in the launching of the function store embeddings in database. And then we're still only going to return the embedding on that request. Obviously, with a system like that, you might want to return different data, like was it successful and things like that. But for the sake of how small these slides are, this is what I can fit on the screen. I'll spend a few minutes discussing specialized vector databases. We've seen just a tremendous uptick in the number of databases that support vectors, and specifically databases that are designed for vectors. The problem with all of them comes down to not having that context that lives around the rest of your data. So there's limited SQL support. They're built only to store those vectors and its associated metadata. They do take a long time to index. They don't necessarily have enterprise features such as scale out, HA, backup and recovery, things of that nature. Some of them have some scalability and performance issues, but more than any of that, it's another piece of the puzzle to maintain. And when you're writing your applications, you don't just want to interact with vectors, you also need all that contextual data around your business as well. And that's where having a database that can cover all those features is extremely important. Because just having the vectors doesn't mean you have the context. It doesn't mean that you're going to have an improved experience inside of your AI application. So basically, when it comes down to having a contextual database, you need to have all the data that is actually relevant to your company or to the application itself. More data, more better. You want to be able to join both your vectors and the transactional data alongside with analytical data. You want to be able to mix and match what you need there in your queries to get exactly what makes sense for your data. So you might want to, if I'm looking for a book, sci-fi book that most commonly aligns with The Martian, and I want the price to be less than $20, there are a number of things that in that conversation flow that need to be pulled out, and the context is really important there. So the context of it being less than $20 and then it being a sci-fi novel and things like that becomes important, because you can filter all of your company data and then do your dot product against those embeddings to really get down to something that makes a lot more sense. So after everything that we talked about so far, it really comes down to a few things that we need to actually deploy. So one being your reverse proxy. That reverse proxy, depending on how you're deploying things, could be Traefik, could be Nginx, any number of things. But basically, you want to be able to terminate SSL, you want to be able to load balance, things like that. Your actual custom applications, that could be a number of things. I'm not even going to begin to dive into that. But then the API that fronts your LLM. And a lot of the way I explain things today, a lot of that is actually being done inside the API server itself. Obviously, you could break that out to like a gRPC connection out to something else that would be running the actual AI component of it. So you may have a couple more things to deploy there. And then you, of course, need SingleStore database as well. So what does the infrastructure look like? The requirements would be, one, that it meets that it can run everything that we just mentioned, but it also needs to have private connections between all those components. It does need to be highly performant. It needs to be able to scale as your model sizes and your data sets grow. And if you want to do additional training, you want to be able to bring on GPU nodes or things like that, you need to be able to add that in as well. And it needs to be flexible enough that you can actually introduce new applications or instance types. And that's where you're adding in GPU nodes, or you want to bring in another application that was developed by your BI team, and they need Tableau to be able to query against all these things, right? So you want to be able to bring in all those things down the road. And for that, EKS really comes to mind for us. Amazon EKS is what I run. I run a lot of our infrastructure on. It's as far as like the tech marketing team, it's extremely powerful. You can either deploy it as just like simple serverless containers, or you can run actual EC2 worker nodes. But at the end of the day, super easy to stand up and get running, start consuming. And then we are big believers in using Amazon Private Link to create these private LLMs, these private networks. They can connect your on-prem data center to your VPC, your on-prem data center into the AWS marketplace to your services running there. So there are a number of ways that we can interconnect and make sure that you're getting that private network LLM experience that you're looking for. So the third piece of the puzzle being the LLM itself. There are so many models out there, and without knowing your data and what you're looking for, it's hard to really say, how exactly do I need to choose? But really it comes down to most of the LLMs are trained in a generic genre of what they're trying to solve for. So ChatGPT is fairly broad in what it's trained on. We'll see some of the numbers on this here in a minute. But you can get some more edge case type models depending on what you need. But basically, usually the larger the model is, generally it has more points of training, but it also was much more expensive to train. But it also means that it can handle more edge cases, and it might be more accurate. So there are a lot of trade-offs with LLMs, and I think it's a matter of kind of balancing that, does this provide what we need? But beyond that, you can still work with a fairly generic text LLM that can just generate text for you, as long as you're providing the additional context that you need. Using something that already exists that's moderately generic allows you to not spend hundreds and hundreds and hundreds of hours training your own models and the content or the cost that is associated with that. Now, if you look at just a few of the models that are offered by OpenAI, you've got Ada, Babbage, Curie, DaVinci. The parameters that they're trained on ramps up really quickly. So I think one of the big things that you would immediately think about is, well, why don't I just use DaVinci for everything? And the problem is the cost. So if you look on their cost page, you can see pretty quickly that if I'm querying DaVinci over Ada, I think it's like 4 or 5x cost difference. That adds up really quickly. So being able to swap the models out based on how expensive the project is, and by expensive I mean not like more about how important it is. Using like a temperature model, right? Is this an extremely important project? Maybe we need to be more accurate, right? So we can switch models out if there's a cost analysis that needs to be done there. But looking at the parameters and how they're trained is important. But at the end of the day, I think most people, when they're developing their LLM and the model in which they're interfacing with their private LLM, they need to swap the models in and out to see what gets them the most accurate responses. But more than that, they also need to look into how much data that they can operate on with the context that they're given. Now, high level infrastructure, how it's all tied together. Overall, fairly basic. There's a lot of things on the screen, but it shouldn't be that difficult. You've got your AWS cloud in black there, the big black square. Inside of AWS Cloud on the left, we've got SingleStore running as a service. AWS Private Link links that into the VPC inside of your account. That enables you to then connect it out to your EKS cluster. You can create the firewall rules to allow your certain applications to communicate with Fast API. The Fast API would be the one that then communicates back to SingleStore. Beyond that, you can use Private Link to then also connect out to your on-premise data center if you have something that you want to connect to there. So all of that keeps everything private. And if you're storing the models locally and querying them locally, there's no connections being made out to OpenAI or somebody else. So the rough flow, you have a user here that wants to find invoices where the payments don't match the invoice value. You query Fast API. Fast API then creates a vector of your question, and then it filters the vector based on the context of that question. Basically, it goes in and it sees, I've got invoice value and payments, and I'm going to dig into the payments table and invoices table, and then start kind of going in from there. It will match similar vectors, and then it'll re-rank those results using .product and some filters. And then once we have all that data really put together, and with the context, it can send that query and the context out to your LLM, which then can come back with a more cogent response that is more accurate. That response is then passed back to your customer or to the app that was requesting it. And that's the rough idea of how these flows would work. You'll notice down below, we're going to input in the bottom right from OLTP and OLAP databases. Kafka is another source. I mean, there's a number of sources that we can use to pipeline data into SingleStore as well to give you that broader picture of context. So we used a similar method of shoving all of our documentation and forum data and all these things into our database to create our chatbot Squirrel. Squirrel is also very well integrated into our notebooks platform, which is what I'm going to show today. So I'm going to pop out here. Okay. Hopefully I didn't get logged out in that 30 minutes.
Hey, Wes, do you think this is a good should we show that slide really quick that talks about the yeah, perfect. So we just want to let everybody know that we'd love for you to follow along with Wes's demo today. In fact, if you sign up right now, you will be entered for a chance to win branded AirPods Pro. We're going to announce the winner at the end of today's session. So just visit this link. There's a QR code also on the screen if you prefer snapping a photo of that. Or there's the bit.ly link, private-LLM-raffle, which I just put in the chat, and I'm happy to send you separately as well. But once again, click that link, sign up for that free trial, and follow along, and we'll keep a track of people that are coming in, and we'll announce a winner at the end of Wes's demonstration.
Awesome.
Thanks, Wes.
Yeah, of course. All right. So I am going to pop this guy out real quick. Hopefully it didn't switch. Yeah. So you're still seeing the portal, correct? Yeah. Okay.
Correct.
All right. All right. Sorry, I'm rearranging my screens here so I don't lose my mind. All right. So we talked about a whole bunch of things today, but really at the end of the day, what's interesting is actually being able to code with a bot. So I mentioned some of the pain that I'd had using ChatGPT. It really becomes interesting when you're using something that is intimately familiar with the product that you're working on, right? So I want to build a SQL or a table that takes hold on, so I don't lose my spot here. There it is. That takes some data and stores it into tables, into a table. Data will include an auto incrementing integer as an ID, a supplied ID that will be an integer, a type, which will be a string, and an embedding, which should be a blob. Can you write me the
Hey, Wes, any way to click that plus button, make this screen any larger?
Yep.
Thanks.
Yep. Zoom in. Better?
That is better. Yes, thank you.
Okay, I'll go one more. All right. So can you write me a method, the SQL scenario to create that table, generate? So while Squirrel is oh, okay, there we go. So create the table name, ID, integer, auto increment, primary key, supplied int, type, varchar embedding blob. So there you go. There's your SQL, all created by our bot. Heavily trained in SQL, so he should know what he's talking about. Helps to use the right thing there. God, I have a key failing on my keyboard right now. Okay, and then I'm gonna run that. And now if I go over to my database, and you'll see here, I chose my database here that it's connected to for this notebook. So if I hop over to my databases, private LLM, I didn't change the table name, so the table name is there. And here we go. So we have ID, supplied ID, type, embedding. Let's go back over here. Sometimes these take a moment to load. Okay. I forgot to hit save, my bad. All right, so we're gonna code with squirrel. Could you write me a Python function to store supplied data in the my_table table in the formats the table expects? Let's drop that in here. Oh, add cell. There we go. Just use our feature there. So basically, it's going to use import SingleStore as S2. Here's the store data in the table. All of this, so we can actually replace that with connection underscore URL, I believe. And then the statement is going to be entered into table name, the values. Obviously, I didn't really give it a lot of context there. So it came back and it needs a little bit of love to make this so it's a little bit more accurate for our situation. But you can see that inside of notebooks, we're able to communicate with a GPT-backed bot who can help write either Python, SQL, or whatever we need to in order to get the most out of our experience here. This was all trained on top of all of our data about our product, our platform, best practices, documentation, SQL best practices to ensure that we're able to get you as far as you can and as far as you need to go. So I think with that, we will pop over to talk about everything else, maybe some live Q&A.
Awesome. All right, I will start pulling up a couple of these questions, and I know we can also, we've got a lot of questions, so I don't know if we will get through everything, but we can start with one. This one, Wes, came in early. It was for you. It's by RJ. It's Wes. Where do you see LLMs in the next 1 to 2 years? Will there be a marketplace of LLMs? What do you think?
That's interesting. A marketplace of LLMs being something that I can query openly. I could see that. Yeah, I could easily see there being a marketplace for that. I think the industry is very, very new as far as how they can be used and implemented, and I think there's going to be more and more folks that are going to be building something similar to what we talked about today, and then they can open those up as services, similar to how OpenAI has done that. So I imagine that we're going to see a lot more things come out. The trick will be, the specialization of those models, and what are they best used for. And then if you could abstract all the models behind one API and basically I feed it in some context of what I have a need for in my request and let the system decide what model may best serve that, that's a whole nother way that you could do something like that. So I definitely think, there's going to be a lot of things that burst out. Like there's, I don't know, 200 vector databases I feel like that popped up in the last 2 months. Those all get slimmed down. The same thing will probably happen here. You'll see a lot of public-based LLMs that are going to show up over the next few months, and then they're going to slim down to the ones that really succeed and find the market fit.
That makes sense. Here's another one. This one's from Luca. It's, at what point does developing an AI trained on company data make more sense than utilizing the knowledge bases and dumps in files, tables, and such?
Might lend on Eric on this a little bit here.
Can you repeat the question? It's, at what point does developing an AI trained on company data make more sense than utilizing knowledge bases and dumps in files, tables, and such?
Okay, so I think I'm going to generalize this a bit about, how do you use company data to like influence and improve the quality of your question answering. And that's one element of it. Another element of it is, are you really going to train a new LLM with company data? So we have like some customers that are doing semantic search on their own data with SingleStore, and then and they want to answer a question. They take the question, get a vector embedding for it, do semantic search of some of their own data using, and the semantic search is done with a vector similarity search, like with dot product. Then they take the close matches and they submit that to the question answering API on the LLM, like the OpenAI question answering API. They pass that as context. So one way you can have sort of, a very large set of company data that can contribute to question answering is, put in a database with a vector embedding associated with it, do semantic search on it, and then you get question answers based on that context. Another element of improving question answering on company data may be build your own vector embeddings on your data. Create your own deep neural network models, like by training with PyTorch, for example, and create a new model that can give you LLMs, that can give you vector embeddings for your data. Like we're working with a customer who's doing entity resolution, where they have some data and they're training, a neural network with PyTorch, and then they can take, new data and get vector embeddings for the new data and do semantic search on some, custom data fields. So as I know that's kind of a long-winded answer, but in summary, either use semantic search and to get great context to answer questions more, in a more powerful way, or even train your own models using PyTorch or other tools to get vector embeddings for your data.
One is just way more computationally expensive than the other. Yeah.
I mean, once you've trained the model, it's not so expensive. Training the model can be very expensive. Yes.
Fair. Yeah.
Good stuff. Okay, we got probably at least 10 more minutes for questions. So I've got a long list here. And then after that's up, I'll be sure to announce the AirPods winner before wrapping up. This one was from Arpit. It was for Wes, but I know Akmal actually already answered it in the chat, but I thought it was a good one. So, either of you are welcome to chime in on this. It's, hi, Wes, how does deploying LLM on a private network impact scalability and performance compared to using it on a public network?
As far as when you're saying that, are you meaning using an already publicly available one, or are we referring to something that is, your own that you make available on the public internet? I think this is more about privacy at the end of the day than it is about anything else there. If I'm hosting the same thing in AWS, it doesn't really matter, if it most likely isn't going to matter if I'm accessing on the public IP versus the private IP. You know, if I want to keep that data connection private at, you know, between the top of rack and back down again, or wherever it is inside of Amazon's data center, that's a different story, right? We could be shaving off milliseconds. It really depends on routing and things like that. But at the end of the day, I don't know that it'll directly affect performance, but it's definitely more about security.
Good stuff. All right, this one from David Kim, it was for Eric. If you are still using the API of OpenAI, how does that provide privacy?
The OpenAI APIs can provide privacy in a couple of ways. One is, you know, your connections are secure, and OpenAI isn't sharing your data with others. I'm not familiar with the specifics of this, but I'm pretty sure that there are ways to tell them not to retain the history from your queries. So there are ways to make it secure. So, you know, no one's going to decrypt your SSL traffic. You know, it's secret as it's traveling from your app to OpenAI. Also, Azure OpenAI has enterprise SKUs, or, you know, products that they sell that are basically making that their LLM available in a sort of a even more secure setting where the data doesn't travel over the public internet, and, you know, there's more security around the communication between your application and the servers that are, you know, giving you the vector embeddings and answering questions.
Yeah, and I think, yeah, I think somebody else mentioned keeping on top of legislation in your country and things like that, as the legislation is changing very rapidly. So that's important as well. But you don't have to just use OpenAI, right? There are lots of other models that can actually be downloaded and run locally. If you can access the model through Hugging Face, there's options to download a lot of them and choose to run them locally. And then you're not making any queries at all to their APIs. So, you know, yeah, I think the webinar today calls out OpenAI, but if you find a model that you can use for your data, and it's one that you can freely download, then you don't have to worry about that at all, because it is all happening inside your data center.
Good stuff. This one was from Prakash. I think Eric answered it, but I thought it was a good one. It was, do we have to store the embeddings and vectors in each private scenario, or can we do analysis on the fly without having to store those embeddings and vectors?
I mean, yes, you can. Go ahead, Eric.
Yeah, I think the short answer is yes, you can. Like I think my answer that I typed was, you know, basically you can get context for your question answering API before, you know, either on the fly, or you can query a database using semantic search to get the context, and then use that as the to send to your question answering API. So one's on the fly, one's from extracting it from a database.
Yeah. And I think there's a difference here. So there's two embeddings at play, right? There's the embeddings of the data that you're querying against, which would be like the rows in your tables of company data. Then there's the embedding of the actual query itself. And the query itself, you can get the embedding of and most likely throw out. But it's more about the embeddings in the table. What you want to do is you want to store that alongside each row if you can, or reference, you know, another table that has them. But you want to be able to reference that data down the road, because if you've got, you know, a billion rows, you don't want to create the embeddings of a billion rows in order to scan against every billion row, you know, all the billion rows each time I query that data. So storing is important for the data that isn't changing, but for the query itself, you can toss that out.
Good stuff. All right. This one's from Parviz. It's, you know, Wes or others. It is, can you provide prompt example or recommendations for better accuracy and performance?
I am far from a prompt engineer, although I believe I could be, maybe making some more money being a prompt engineer right now. But yeah, I'm horrible at writing prompts, so I'm the wrong person to answer that.
Good stuff. Here's a good question. I think it's just, this question is about distinguishing what is SingleStore's value proposition versus the OpenAI or, LangChain or whatever. The question is, do you help to build the LLM models itself, or are you just for the infrastructure for storage? I don't know if you want to take that, Wes, or if you want to, hit that over to Eric, who's been around for so long.
Yeah, let's let Eric talk about that for a
Okay.
minute.
Eric.
Sure. Yeah, we're the infrastructure for storing your vector data and querying it with all other kinds of data. So, most question answering situations do have like a semantic search component where you find some context for a query, and then you submit that context back to the question answering API. And we are a really good place to put that context into some information and semantic search that information. There's a pretty neat blog we have about semantic search. If you just Google for SingleStore semantic search, you'll find it. And the neat thing about SingleStore is that because we have full SQL capability, you can have a table that has, say, a vector embedding column implemented as a blob, as Wes talked about today, and then several other columns with descriptive data, like the original text that vector came from, and maybe some properties or categories, links to other tables. So you can query it in a really powerful way. You don't have to just like do simple, filters and, top K search. You can do joins and window functions and other, full text mixed with vector similarity search. So that's one of the reasons people like it, is because of the power of sort of full SQL mixed with vector similarity.
Yeah, and I dropped a link.
Go ahead,
Matt,
Wes.
if you want to. I dropped the link to that blog post if you want to share it with everybody.
Perfect. Will do. I'll share that as soon as I post.
Eric and Pranav.
Okay. I'll share that out as soon as I pose this next question. This one was for you, Wes. And I know I've already told the audience that we're going to be sharing the video of this after the session ends. But this question is it possible to show us how the setup was done step by step for beginners? I'm curious to know how the entire architecture was built. So I know you've got some assets that we're going to be sharing via email, but wonder if you can just elaborate on that for a second.
So today was largely an exploration in how the architecture can be built. So there's no actual running system underneath of this today. I am in progress of building something that I am able to share. It's a little bit slower than I'd like, but I'm working inside of like I'm having a new tech marketing EKS cluster deployed that is under IT's management and things like that. So I've got some work that we're doing to actually get this up and running and have like a full system that is private that we can share on these webinars. But today I shared more of the methodology and the thought process that went around choosing the pieces that we're going to use to build that. And Matt, we'll schedule a follow-up where we're actually going to do maybe a more technical deep dive into the architecture itself. But it'll probably be 6-ish weeks out before that's all stood up and ready.
Good stuff. All right, and I shared that blog post. And by the way, I should also mention, there's no way we've got over like maybe 90 questions. There's no way we're going to get to everything today. We will be following up with everyone via email, so just stay tuned for that. I might have time for 1 or 2 more questions before we wrap things up and announce the AirPods winner. This question was interesting. It's from Jason. It's, can the bot be built this way to serve as a knowledge expert for the private company for the purpose of product development, process development? I know, obviously SingleStore has built our own little squirrel bot. Wes, I don't know if you want to take that or delegate it, up to you.
Yeah, 100%. So Squirrelbot is largely built on public-facing content, right, and kind of our architectural stuff. But if you wanted something that was more internal, I mean, that's all about what data you give it access to or what you train it on, right? So if I'm, giving it access to Jira and to, Salesforce and whatever my help desk system is and all these things, then yeah, it can become that expert, right? I think it's just a matter of the data and the training at the end of the day. But I could easily see, somewhere on a corporate intranet, a bot like this where it's like, hey, how do I get information about my health benefits? Where do I go? Right. I've worked for some really big organizations and I can't find anything. So yeah, I understand where that could actually be really helpful. Because if you're relying on a SharePoint page that was hopefully very well curated, I'm probably not going to be able to find what I need. So yeah, totally possible.
Good stuff. One thing I want to clarify, I saw some people thinking that I was politely saying that Eric is old. That was not what I was saying. I was saying that he has been around at SingleStore longer than the rest of us on this panel. So he knows the most about SingleStore. And Eric has like PhDs and, I don't know, math, artificial intelligence or something. He knows this way better than us. So that's what I meant by that.
Computer science.
Computer science, sorry. With just a few minutes left, I'll ask Wes, Eric, Akmal, is there a favorite question that you saw that you would love to answer publicly before we wrap things up? Anyone?
Let me read back through. I think Akmal should talk a little bit about hallucinations. So Chinmoy, how do we ensure data quality from an LLM to avoid hallucinations?
Akmal, you still on? Are you on mute?
Yeah, sorry, I'm eating my dinner. So there you go. It's public news. So that's why I was quiet. Okay, so yeah, the hallucinations, big problem, of course. And this is, when you use one of these something like ChatGPT Bard, for example, I mean, there are disclaimers. It does warn you that the results you get may be wrong and even dangerous. And that, I think, is one of the problems of having such a vast quantity of data on which you've kind of learned. The AI has kind of gone beyond what we might have expected it to go on. Challenging problem. I don't know what's a good solution. I mean, if you're training something on pretty much anything that it can find on the internet, on whatever's in the world, that's an awful lot of data, and it's kind of come to the point where the AI is starting to make things up by itself. That's very, very interesting and concerning, I would say. But I don't have a good answer for that, other than I think that certainly at the kind of scale that we work and the vector storage that we do, we certainly can focus very much on the accuracy and getting back the results that we're looking for and the customers are looking for. But it's a challenge. Sorry, I'm thinking about it because I'm going to be doing a presentation on it soon. So as soon as I've got some ideas, I'll blog it, which I normally do. That's the best way to do it. So give me a bit of time.
I saw your abstract for that, so I thought I'd put you on the spot.
No, it's okay. Absolutely. I mean, it's a great question because it's very relevant. I mean, absolutely. I see it myself. So quick example, and I know we're almost out of time. So over the past couple of months, there's a bit of research I've been doing using ChatGPT Bard, for example, and they come up with responses and links to resources that they claim exist. I follow these through and try and find them, and they don't. Nowhere to be seen. It's kind of making stuff up as it goes along. And like I said, that's concerning. And this has led to problems, as you know, in the news, in terms of legal profession. Solicitors, lawyers have been got into trouble as a result of this. And that has consequences. And that's very worrying. Okay, so there is a concerning aspect to this. I'm afraid I don't have a good solution to it. And now, like I said, I'm thinking about it. And so probably I'll put my ideas down in a blog post. I think that might be the best way.
All right, great. We're at time, so I'm going to make this quick, wrap up and announce the AirPods winner. If you like this OpenAI topic, join us again next week. Wes, can you pull up that slide one more time, the webinar for next week? I'll put this in the chat as well. We're going to be presenting how to build an OpenAI basketball referee with computer vision. Really fun topic. Register right now. I just put the bit.ly in the chat, so take a look at that. Now the announcement you've been waiting for. Today's AirPods winner goes to Isaac Patisse, who is a language information architect at Oxford University Press. That sounds like a fun job, especially in this context. Very cool. Congrats. Thank you for joining. If that's not you, don't give up. We're going to announce one more AirPods winner by the end of the day for anyone who has tried out SingleStore's free trial or active in our trial or our account today. So keep a lookout for that email. Thank you, Wes, for an awesome presentation. Thank you, Eric and Akmal, for joining the Q&A. We'll try to answer everyone's questions by email. And thank you to everyone for attending the webinar today. Thanks so much and have a great day.
Hey, thanks.
Thank
Thanks,
you.
everybody.
Bye, everyone.
Bye.